Um, Module 12, network troubleshooting. Model objective would be troubleshooting enterprise network. We will talk about these subtopics: network documentation, troubleshooting process, troubleshooting tools, symptom and causes of a network problem, troubleshooting IP connectivity. Topic objective would be for network documentation, explain how network documentation is developed and used to troubleshoot network issues. Troubleshooting process, compare troubleshooting methods that use uh, a systematic layered approach. Troubleshooting tools, describe different networking troubleshooting tools. Symptoms and causes of a network problems, determine the symptoms and the causes of a network problem, and so on. And troubleshooting IP connectivity, troubleshoot a network using a layered model. Now 12.1, network documentation. Documentation overview. So let's first of all let's know what is the documentation overview. Is an accurate and a complete network documentation is required to effectively monitor and troubleshoot networks. Common network documentation include the following. First of all, physical and logical topology of the overall network. Then network device documentation that record all pertinent device information. Then network performance baseline documentation. We will talk about what is the network performance baseline, and we will talk about uh, the network device documentation and physical and logical topology, what is the difference between each one, and so on. All network documentation should be kept in a single location, and of course there need to be a backup documentation, and it's a must that that backup need to be in a separate location. So if that, let's say, if that specific hard drive or a server goes down, we will not lose our all documentation in one time. Now, physical topology and a logical topology. We talked about what we should have a physical and logical topology diagram in our documentation. Now, you see in the physical topology, we will have main office, for instance, and let's say that it is the main office in a building A, room 107, and it's a closet 1, rack 2, shelf 1, rack 1, shelf 1, rack 2, shelf 1, rack 2, shelf 2, rack 2, shelf 3, and so on. We will know the place, exact place of the routers. However, in the logical topology, we will know the IP addresses, the gigabyte interfaces, and so on. Of course, the VLANs, if there's a port aggregation, and the IP address of each interfaces, so we know our topology. Now, in network device documentation, we will have documentation should be contained and accurate. It should be accurate in here. The name, the IP addresses, and every other detail need to be accurate and up to date. Because sometimes in our network we will change something, so we need to update our documentation accordingly. And of course, for the softwares and the hardwares, documentation should include all pertinent information about the network devices. So now we will take a look at the router device documentation. The device, we will so these are the standard framework. We might have some changes and so on. However, these are the standard: device and the model, description, location, iOS or the operating system, and the license. Now, interfaces, description, IPv4 address, IPv4 MAC address, and routing for all of the interfaces. And of course, each interface has its own description. What is the IP address of that interface, and the IPv6 address, MAC address, and routing that has been used. For the switch, same device and model description, and so on. We will have all of these. However, we will have also the access. Access means if it has access or not, if it is VLAN or not, if it is trunk or not, either channel, port channel 1, port channel 1, if it is native VLAN, and enabled or disabled. Sometimes we may have a lot of interfaces, however, not all of them are enabled. So in this case, these two are shut, so they means it's shut down. Now, in system documentation, we will have a server 1, server 2, and PC 1. Now, the operating system of each one is mandatory. You need to put in the service that they will provide. Each server will provide a MAC address, IPv4 and v6, default gateway, and a DNS. If there's a DNS, of course, in a real example, we will have a DNS. Now, establish a network baseline. Why we need it and what is the network baseline. A network baseline is used to establish a normal network performance to determine the personality of a network under a normal condition. What do we mean by this? We will talk about it. Establishing a network performance baseline require collecting performance data from ports and devices that are essential to a network operation. A baseline data is as follow. Provide insight into whether the current network design can meet business requirements. Sometimes we created a network, we need to make sure that this is what the company has asked for. And also can reveal area of congestion and area of network that are underutilized. Sometimes you may give a lot of bandwidth for a specific place or some specific ports. However, you see afterward that, well, actually it is not that important, and somewhere else we need to give it more bandwidth and give it more cables for load balancing and so on. Now, step one to determine what type of data to collect for baseline performance. When conducting the initial baseline, start by selecting a few variables, okay? However, after some time, you may see that these are not sufficient. You can start fine-tuning. However, make sure that in the first you will not choose a lot of variables. So because it would be overwhelming and it will make your analyzing very difficult. And you might ask, what is the variable? A variable are those criteria that you will use in order to create your baseline to see how would your network will work in a very normal day. So that would be your baseline. And in here says the interface utilization, the usage of a port, and a CPU utilization of, let's say, a device, a router or a switch. It would be a baseline creation. Now, step two would be identify the device and the port of interest. So sometime you may see that, well, not all of the devices are important for me, or not all the ports are important for me. Some of these importance are servers, and yeah, these two servers, those ports, and some port of the switch, and this PC terminal, which it would be admin terminal also. These are the importance. We need to make sure that these are the variables that we will choose. So when I say a variable, the server along by itself would be a variable, this port would be a variable, and this PC would be a variable. Now determine the baseline duration. Most probably between 2 to 4 weeks is a baseline adequate, as in here says. 2 to 4 week baseline is adequate, it's average. However, if you have like a long-term trend you need to be measured, at that time you may have up to 6 weeks. Until 6 weeks is okay. However, after that it would be a lot, and after a while you need to analyze. At that time you will have some problems with analyzing, and of course annual analyzing it would be very good. And a baseline different section on a network on a rotating basis. So sometimes you see that some departments have a lot of problems. So sometimes you would create an analysis or a baseline measurement for only those departments. You will check them annually, or let's say 2 to 3 months. Every 2 to 3 months you will check them. So yeah, it's a good to have an annual, or sometime even 2 to 3 months. One time you can have your analysis for those departments that have problems. Analysis must be conducted regularly, as it here says. Yeah, regularly to understand how your network affected by growth and other changes. So when you do analysis more often, sometimes a CEO or someone might ask you, what if we add 10 pieces in this department? So that time, if you have your analysis and you checked it regularly, you will know that how much PC your network would be able to handle. That's good. That would be one of the advantages of analysis that's been uh, worked on or been held every now and then. This table will list some of most common Cisco iOS commands used for data collection. So for data collection, you can use these commands, and it is like a show version, show IP interface. Of course, the brief is kind of important. Show IP route, show CDB neighbors, ARP, IPv6 neighbors, show running config, VLAN, port, and tech support. It is all important to take a look at it. For instance, the show version display time version information for device and software hardware. The show IP interface, it will display all the configuration options that are set to the interface. Anything that you put on any interface, in here you can monitor it and take a look at it. Display and the show interface display detailed output for tag interface. In here we have show IP interfaces brief. In here says show interface, so it will give you all the interfaces. Show IP routes, show IPv6 route, static, EIGRP, OSPF, BGP, ISIS, and so on. We have a lot. It will display a routing table content list in directly connected networks and learn to remove from remote networks. Show CDB neighbors details, display detailed information about directly connected Cisco devices. ARP and IPv6 also important, display content of ARP table, IPv4 and neighbor tables. Show running config, we all know by now what the show running config display current configuration that happening over the router or a switch. Show VLAN, show port or tech support, these are all useful commands that you can use. Now 12.2 troubleshooting process. Now general troubleshooting procedure might be varied because you and another network engineer, you may create your network different, your problem would be different, and of course your experience would be different. However, this is a framework that you may use for troubleshooting. Using a structured troubleshooting method will shorten overall troubleshooting time. Okay, so it's kind of, it will have its own benefit. There are several troubleshooting processes that can be used to solve a problem. The stage one, gather symptoms. What are the symptoms? What do you feel? What do you think that your network might have? And that seems to be a problem. Stage 3, implementing corrective action. If you implemented a corrective action and the problem was solved, you can document the solution. If not, you need to undo it, because sometimes it will cause some other problems too. That you need to undo it and try to do any other action that might fix the problem. So the 7-step troubleshooting process, this is like a fishbone chart. We have something defining a root cause analysis, which names is fishbone chart. We have these 7 steps defining a problem. Once you define a problem, now you should know what is the problem and define it properly. Then gather information. What are the targets, hosts, devices are identified and assessed, and information is gathered. Now analyze the information that you have. Identify possible cause using the network documentation, network baseline, knowledge base, your knowledge, of course, and peers. Eliminate the possible causes. Sometimes you may see, well, this router is not, it's right that the switch is not working. However, this router has no job of when the switch is not working, so I will just remove this router out of my list. Then propose a hypothesis. You may say, well, I think that this switch, the main problem that the switch is not working is this at this point. I think that the switch has a power cord problem. Maybe the PDU was turned off, and so you will test your hypothesis. You will check the power cord. You will check the cables, LAN cables. If they solve, then after the test hypothesis, solve the problem. When solved, involve document that the cause and solution to help solve future problems. So first you will define a problem, then you gather information. In gathering information, of course, when you have your information, you will propose a hypothesis. Sometimes you may need to analyze the information that you have, of course, at the same time of proposing the hypothesis. If you propose your hypothesis and you thought that you need to test it, yes, you can test it. If the test was correct, you have a prior problem and you need to update the documentation. Now, if you didn't have, you need to eliminate that possible cause. Okay, you may say, well, the switch power cord has no problem. You need to eliminate it, so you will not do it, redo it again, and return back to gather information. And you will go uh, through this fishbone chart. If problem was solved or not, you will check it again and again. Now, question end users. There are some questions that you may ask uh, the end users, so you know, so you understand your problem more better. So first of all would be, what does not work? Well, what exactly is the problem? What are you trying to accomplish? Sometimes the user might say, well, my network is not working properly. I cannot access my account. I cannot do what, so and so. Well, sometime there might be a problem with the access list. We will cover in the transport layer problems, troubleshoots. Sometimes that user would think that they can access finance department. Well, they cannot. That's why, because they are blocked using the access control list. However, they don't know. So what are you trying to accomplish might be a very good question. And there's a lot of other question. What did the issue affect? Is it just you or other? Or is it only you that you cannot access internet, or also your other computers that cannot, or your colleagues cannot also? When does exactly the problem occur? When was the problem first noticed? Where are the error message displayed or not? And so on. These are the good questions that you may ask to get to the bottom of your problem. Now, for gathering information, you can use these commands: ping, trace route, so you know the path of a packet, where it goes and where it returns back. The telnet, the SSH, or show IP interface brief, show IPv6 interface brief, show IP route, show IPv6 route, show protocols, display all global interface specific status and configure layer 3 protocol, and debug. These are the common Cisco commands that you may use. And troubleshooting with layered models. The OSI and TCP/IP model can be applied to isolate network problems when troubleshooting. So if an end user have a problem, you will check application, presentation, and session layer. Most probably in these layers you would have problem. Well, if a transport layer or a network layer, transport layer we mean like ACL, network layer like IP address or accessing internet. The data link layer would be a standard switch, a physical layer, or it would be a hub. So you can check these layers and also their represented devices. Now we have a structured troubleshooting method. Different troubleshooting approaches that can be used can be used include the following: bottom up. This approach, when we can work with this approach, when we suspect that the problem is the physical one. The top down would be when we suspect that the problem is piece of software. The divide and conquer, it will start at the middle layer. Of course, layer 3 would be the middle layer, and both direction. Follow the path would be used to discover actual traffic path from a source destination to this scope of troubleshooting. Substitution, you physically swap suspect a problematic device with a known working one. So you have a switch, it is not working properly, you will bring another switch, you will copy the configuration of that switch, of course, before you have it, and then you will have the other switch to see if it is working or not. Comparison, attempt to resolve a problem by comparing non-operational element with a working one. So you see if this one is non-operational and it does not work, how is the status compared to the this one that is work. Educated guess, sometimes it would be based on your troubleshooting experience. This would be after 2 to 3 years with that network, you will have some guesses that you think that, well, if this switch is not working because it is overutilized, you may say that. Guidelines for selecting troubleshooting method. So to quickly resolve a network problem, take the time to select the most effective network troubleshooting method. This figure will help us. So if for defining the problem, uh, we have determined the type of problem. If it was software oriented, so software related, top-down method is a very good approach. Hardware would be cable oriented or complex, would be bottom-up method would be good. Now apply analyze the symptoms and apply previous experiences. If there's a new problem, bottom up again. If the is experienced before, divide and conquer would be a good solution for this. Now 12.3, troubleshooting processes. Now we have a software tools that we can use to troubleshoot the problems that we have in our network. Network software include device level monitoring, configuration in the network management system tools, of course. We will have network software include device level monitoring, configuration, and fault management tools. This tool can be used to investigate and correct network problems. Knowledge base would be online network device vendor knowledge bases have become indispensable source of information. And when a vendor-based knowledge base are combined with the internet search engines, a network administrator has access to a vast pool of experience based on information. Now, baseline tools, many tools for automating the network documentation and baseline process are available. Baseline tools helps to count documentation, take a such a network diagram, update the network, software and hardware documentation, and of course, cost effectively measure the baseline network bandwidth used. And now we have a protocol analyzer, Wireshark. A protocol analyzer or Wireshark can capture and display the physical layer and application layer information contained in a packet. So it would be good. So the physical and the application layer, this one we can take a look at a package through Wireshark. It will tell us some information about that uh, frame or a packet. Now we have hardware troubleshooting tools. So these are the hardwares. These are the physical ones. Digital multimeter, it will measure electrical values, voltage, current, resistance, and so on. Cable tester is a handheld device, so it means that you is a physical device designed to test various type of data communication tools. A cable analyzer, multifunctional handheld device used to test and certify a copper or a fiber cable. Portable network analyzer, specialized device used in troubleshooting switch network and VLAN. So for VLAN and switch network, we will use a portable network analyzer. Cisco Prime NAM power browser-based interface that displays the device performance analysis in a switched and unrouted environment. Now, syslog server is a troubleshooting. This one is important and because in the previous IMP, so it is important. In the previous exams, these were asked. Syslog is used by syslog clients to send a text-based log message to syslog server. So the thing is, 0 is a very important. 7 is just debugging. Okay, if it's a level 0, it means that's quite important alert and a critical error warning, notification, informational debugging, and so on. Now 12.4 symptoms and causes of the network problems. In a physical layer troubleshooting, the table is common symptoms of physical layer network problems. Performance lower than baseline. If your performance is lower than baseline, it might be require previous baseline for comparison. The most common reason include overload or underpowered server, unsuitable switch or router configuration, traffic congestion on a low link, and a chronic frame loss. This might be the reasons for performance lower than the baseline. Loss of connectivity could be due to a failed or disconnected cable. We can just verify by a ping or searching on internet. Intermittent connectivity loss can indicate a losses or oxidized connection. Sometimes your connection header or RJ45 header might be oxidized. A network bottleneck or congestion. Sometimes we implemented ether channel. We have a lot of cables. We made it one virtually. Now one of the cable is down, or two or three cables are down due to some environmental problem. A mouse came and cut it. So now we have a problem. All the packages are now balanced on those remaining cables. Now we will have some bottleneck or congestions. High CPU utilization rate. Sometimes CPU utilization rate indicate that the device is operating at exceeding design limits. So you design this switch or this router for 24 devices, and now it is 40 devices. At that time, you will have some problems uh, due to the not making sure that your system was scalable at the first time that you designed your network. Now, console error message. Error message reported to a device console cloud indicate that a physical layer problem or console message should be logged in the central syslog server. Now, power related. You may have a power related to a fan and ensure that the chassis intake, the exhausted fan vents are clear. Hardware fault. Sometime a network interface card driver might be problem. A bad cabling or a grounding problem can cause a network transmission error. And the cabling fault. Sometime look for damaged cable. A mice might cut it, and so you will have your damaged cable. Or a poorly crimped connector. Attenuation, noise interface configuration error, exceeding design limits, and CPU overload. These are the type of problems that you will have in a physical layer. Now, in a data link layer, no functionality or connectivity at the network layer or above. There would be a septum. The description for this would be some layer 2 problem can stop exchange frame across the link, while other only cause network performance to degrade. Well, this one is important. Network is operating below baseline performance level. Frame can take suboptimal paths to their destination, but still arrive, causing the network to experience an unexpected high bandwidth usage on a link. Excessive broadcast. Operating system use broadcast and multicast extensively, so also that would be a problem. Console messages. Router send message when it detects a problem with the interpreting incoming frames, or when keep alives are expected but do not arrive. Encapsulation error, address mapping error, framing error, STP failure, or loop. Encapsulation error occurs when a bits placed in a field to sender are not what the receiver expect to see. Well, I will send something that a receiver did not expect that, so there will be an encapsulation and decapsulation error. Address mapping error when a layer 2 and layer addressing is not available. Framing error. Frame can be caused a noisy or serial line, improperly designed cable, a faulty network interface card, duplex mismatch, and incorrect configuration channel service unit, line clog. This would be a framing error. STP failure. Problems are related to forwarding loops and occur when no ports is redundant topology are blocked and traffic forwarded in a cycle indefinitely. So that time you will have an STP. An STP spanning tree protocol would be used to prevent that loop. Network layer, network failure, suboptimal performance. Network failure will occur when a network is nearly or completely non-functional, affecting all users and applications on a network. These failures are usually noticed quickly by users and administrators, of course. Suboptimal performance, just like the layer 2. This involves a subset of user, application, destination, and type of traffic. Optimization issues can be difficult to detect because even hard to isolate and diagnose because usually involve multi-layer. Okay? It's not only one layer, so you cannot find it and say, well, it is only this computer or only this layer. General network issues, often change on a topology may unknowingly have effects on other areas of a network, so you cannot just change your topology and goes like that. Determining whether anything in the network has recently changed, and or if there's anyone currently working on the network infrastructure, that would be a very good question to ask. Connectivity issue. Check any equipment and connectivity problems, including power problem, environmental problem, layer 1 problem, for example, cabling or bad port or ISP problem. Routing table, neighbor issues, topology database. These are also some other points that you need to check. Routing table, check routing table for any unexpected thing or missing routes. A neighbor issue, check if there's a problem with the routers for forming neighbor adjacency. Topology database, check table anything expected such as missing entry or unexpected entry. Well, we have transport layer troubleshooting, and it is access lists. The table lists area where ACL misconfiguration commonly occur. Okay, a selection of a traffic flow. An ACL must be applied on a correct interface in the correct traffic direction. Order of access control entries. The entry is in ACL should be form specific to general. Implicit deny any. The implicit ACE can be the cause of an ACE misconfiguration. Address and IPv4 wildcard masks. Complex IPv4 wildcard masks are more efficient but are more subject to configuration error because sometimes you will not understand it. Well, it's correct that you can use a very good wildcard mask and it might be somehow difficult to understand, but you know it and you can do it. However, not all the engineers will understand it. Sometimes they will change something and it will create a problem for them. Selection of a transport layer protocol is important to only the correct transport layer protocol be specified in ACEs. Source and destination port ensure that the correct inbound and outbound port are specified in ACE. Use established keyword and applying it correctly can provide unexpected result. Uncommon protocols misconfiguration ACL often cause problem protocol other than TCP and UDP. Now, transport layer transfer not for IPv4, BOOTP, and DHCP. The DHCP request packet has source IPv4 address of quad 0. However, not require both valid destination and the source IPv4 address. Therefore, both and DHCP can have a difficulty operating over a router running either static or dynamic NAT. And how to solve this problem? Maybe it would be configuring IPv4 helper. This feature will help to solve this problem, and it will solve it actually. A DNS server outside the NAT router does not have an accurate representation of the network inside the router. So configuration of IPv4 helper again will solve this one too. And SNMP also IPv4 helper will solve it, and so on. Tunneling and encryption protocols also, that would be a problem. Now, application layer troubleshooting. The table provides a short description of those application layer protocols. What is the SSL and Telnet? What is HTTP and FTP, TFTP, SMTP, POP, SNMP, DNS, and NFS? These are the application layer troubleshooting. SSL and Telnet, if you have these applications, they will enable user to establish terminal session, connect with a remote host. You have a router in like a headquarters in Baghdad, you can SSH to it. HTTP, support exchanging of text, graphic, we know it's HTTP or HTTPS, like a web browser or multimedia file on the web. FTP, perform interactive file transfer, perform basic interactive file transfer typically between host and networking device, and so on. Now, troubleshooting IP connectivity. Component of a troubleshooting end-to-end connectivity. Bottom-up approach step when there's no end-to-end connectivity are as follows. So let's say you have no connection anymore, so you will go from the bottom up, so you will go from the simplest thing to the everything. First, you will check a physical connectivity in a point where network communication stops. check the for duplex mismatch, check data link network layer, verify default gateway if it is correct or not, ensure device are determined correct path, so the routing protocol is configured in a good way, verify transport layer functionality properly, verify that there are no ACL blocking that specific traffic, and ensure DNS settings are correct. If you do this, it would be a very good troubleshooting. And usually what indicate troubleshooting effort is discovery that there's a problem with the end-to-end connectivity. Two of the most common utilities used to verify problem, first of all, would be ping and a trace route. In a world of network, ping and trace route are very two common utility that people use. Ping, we can just ping or open a browser to check if we can access a website or a Google, for instance, to check if we have a connectivity or not. Now, step one, to verify the physical layer, the show interface command is useful when troubleshooting a performance related to issue hardware suspected to be a fault. Uh, of of interest in the output are the interface status, input queue, output queue drops, input errors, and output. So in here, the show interface gigabyte, it will tell you this input queue, output queue, input errors. If there's any errors, you would see if it has any error in here, you will see that this might be a problem, and so on. Now, step two, check for duplex mismatch, because every cable and every Ethernet interface will have a duplex. And here, as we can see, it says F020 is full duplex, and in here it says half duplex. Well, this will create a problem. This one, you would have some problem with it. Now this one is switch 1, this one is switch 2, and this one full and this one half. It will be a problem. Now verify addressing on a local network. The ARP address resolution protocol Windows command display and modify entries in the address resolution protocol cache that are used to store IPv4 addresses and the resolve MAC addresses. Now ARP.A you can also do on your computer, this one, and you would see that you have your internet addresses and what is the physical address and what is the type. Now troubleshoot VLAN assignment example. Now we have S1 show MAC address table. We have these 1 and 10. For example, the MAC address on a F0 should be VLAN 10 instead of VLAN 1. Well, in here, the following configuration change everyone to VLAN 10, verify the changes. Now you see that this one, the one, now it is 10. Both of them are 10. And verify default gateway. Sometimes the default gateway, like most of the time, it would be default gateway that the student would not be able to understand it, and it will misconfigure it. In this figure example, we have a gateway of R1. We have R1 is 192.168.1.2 and PC1 is 10.1.10.1 RG00. And useful command to verify the default gateway and show IP route or route print or nest.r. In here, it would be the first IP address as it's shown in here. The first IP address of this subnet would be the default gateway for this computer and for this network. Troubleshoot IPv4 default gateway example. IPv4 gateway can be IPv6 default gateway can be configured manually using SLAAC or by using the HCPv4. As we can see in here, an example PC enabled to acquire IPv6 configuration using the Slack, the command output missing all IPv4 multicast group FF02 double colon 2. As we can see it from here. Now, because this one is missed in here, it cannot get the IPv6 address. That's why it cannot have the IPv6 address. Now, step 5, verify the correct path. When troubleshooting it is often necessary to verify the path to destination network. The figure describes the process for both IPv4 and v6 routing tables. This is the destination IP address. Match routing table, yes. Match the more than one entry. If yes, it go to entry have the same prefix length. No, forward the packet using longest mismatching. And if yes, forward packet using a load balancing. Well, in mismatching table, no. If it was no default route, no, discard packet. If yes, forward the packet. And of course, forwarding the packet mismatch more than one entry, again forward the packet, and so on. Now you see we have another step, verify the transport layer. Telnet, you need to, the most common issues in FA transport layer connectivity include ACL configuration and NAT configuration. So we have NAT and we have ACL. We will have these two. A common tool for testing transport layer functionality is Telnet utility. For example, administrator attempt to Telnet R2 using port 80. Now we have Telnet and using the IPv6 IPv and port 80, it tried to use telnet. Now verify ACL. On a router, there may be ACL prohibited protocol from passing through the interface in the inbound or outbound. Sometimes this ACL would create a problem. So we need to check it. In this example, ACL 100 has been incorrectly configured. That's why we will have a problem. The ACL removed from G00 and configured inbound on S, this one. Now the problem is solved. Verify DNS. The DNS protocol controls the DNS distributed database with which you can map hostname and IP address. When you configure DNS on a device, you can substitute the host name for the IP address with all the commands, such as ping or telnet or command output, and so on. So what is DNS? DNS is we will have 192.168 1.20. We will say this one is, for example, Cisco website. Okay, we will configure this, so there will be a server that will take all the IPs, all of these IPs, and the name will be in here. So when someone will search for the cisco.com, for example, it will go to this IP address. So this would be a DNS and DNS related problem. And of course, for doing all of these troubleshooting, we will have a packet tracer. You can download it, and if you want it, you can ask for. I can give you so you can verify the DSCP or a routing or switching technology or connectivity or any other thing. Thank you very much.